This is section 10.2, part 2. I just want to take a quick minute to review simplifying the radicals. Square root of 49, you want to break that down to two factors where one of the factors is a perfect square. 9 goes into 45, so I'm going to break that down to 9 times 5. And then a to the fourth, I'm good with a to the fourth, so I'm going to bring that down. B to the fifth, I need to break that to b to the fourth times b to the 1 power, or you could just say b. And c to the 6, I can take the square root of c to the 6, so I'm just going to bring it down. Now, if I can take the square root of it, it's going to come outside the radical. Square root of 9 is 3. I cannot take the square root of 5, so it stays inside the radical. Square root of a to the fourth is a to the second, and it comes outside. Square root of b to the fourth is b to the second, and it comes outside. Square root of b, I cannot take the square root of b, so it stays in. Square root of c to the sixth is c to the third. Remember, when you are taking the square root of a variable, you are dividing the root into the exponent. And so that is your answer. Now, the quotient property of a square root, when you have a fraction inside of a radical, you can separate putting the numerator in its own radical and the denominator in its own radical. It's okay to have a radical in the numerator, but you cannot have a radical in the denominator. So you have to get rid of that. The process of getting rid of the radical in the denominator is called rationalizing the denominator. This involves multiplying the numerator and the denominator by a factor that makes the denominator a perfect square. Usually it's multiplying by itself. First, example 4, step 1 is reduce the fraction if possible. Can I reduce 35 over 15? Yes, I can. I can reduce that to 7 over 3. Step 2. Separate by putting the numerator in its own radical and the denominator in its own radical. So that's the square root of 7 over the square root of 3. Now look at the square root of 7. Can I simplify that? No. Can I simplify square root of 3? No. The problem is I cannot have a radical in the denominator. So I am going to multiply by the square root of 3. And rule of algebra, you have to do it on the top. Square root of 7 times square root of 3 is the square root of 21. Square root of 3 times the square root of 3 is square root of 9. Now look at the square root of 21. I cannot simplify that because I know the only two factors of 21 is 3 times 7. And 3 is a prime number and 7 is a prime number. So there are no factors of 21 that's a perfect square. So I'm good there. Look at the denominator. Square root of 9 is 3. So that is simplified. That meets all the requirements. If you will look on the very first panel of 10.2 at the very beginning, it says you cannot have a fraction, you cannot have a fraction inside of a radical, and you cannot have a denominator. Your denominator cannot be a radical. So we are good. Example B, we're going to first reduce. 6 over 12 reduces down to 1/2. So that's 1y over 2. Now I'm going to separate it to put square root of 1y, or I can just say y, over the square root of 2. It's okay to have square root of y in the numerator, but it's not okay to have the square root of 2 in the denominator. So I'm going to multiply. This is called rationalizing the denominator by multiplying top and bottom by the square root of 2. So that I get square root of 2y over square root of 2 times square root of 2 is the square root of 4. But I am good with you skipping that step and going straight to square root of 2 times the square root of 2 is square root of 4. Do that in your head and get 2. We cannot simplify this square root of 2 with this 2 because that's a square root. So we are done. That is my final answer. Example C, it's already separated in its own radical. What you could do is see if you put it over 1. if you put it over one radical, could you reduce that fraction? Can I reduce 3/8? No, you cannot reduce 3/8, so you can skip that step. But always look to see if you can reduce first. Now I'm just going to have to rationalize the denominator. Now, am I going to multiply it by the square root of 8? I can, because like I said earlier, usually you multiply by itself. Now watch what happens. That's the square root of 24n over the square root of 8 times the square root of 8 is the square root of 64, which is 8. Now look at the square root of 24. That can be broken down to 4 times 6. Square root of 4 is 2, so that's 2 square root of 6n over 8. Now I can reduce. 2 goes into 8 4 times. So my final answer is the square root of 6n over 4. Now let me show you another way you could have done this. Looking at your square root table, look at your perfect squares. Could I have multiplied 8 times some number other than itself to give me a perfect square? Yeah, I can multiply 8 times some number to give me square root of 16. What is that number? Square root of 2. So it's not always itself. Sometimes it's other numbers. So in the numerator, that's square root of 6n over square root of 8 times square root of 2 is the square root of 16. And what is the square root of 16? 4. So you get the same answer, but the second method is by far the faster method. Example D, square root of 3/5. Okay, I cannot simplify that, so I'm just going to recopy it, separating the numerator in its own radical and the denominator in its own radical. Now I am going to rationalize the denominator by multiplying both top and bottom by the square root of 5. So in my numerator I get square root of 15 over square root of 5 times the square root of 5 is the square root of 25, which is 5. And that is my answer because I cannot simplify square root of 15 over 5. Example E. I cannot have a radical in the denominator, so I'm going to have to rationalize the denominator by multiplying top and bottom by the square root of 3. So 1 times the square root of 3 is 1 square root of 3, or I could just say 3. Over square root of 3 times the square root of 3 is 3. And then I am done. It is okay to have a radical in the numerator. You just cannot have it in the denominator. Let's do some practice problems. Number 1. I cannot have that radical in the denominator, so I'm going to rationalize the denominator by multiplying both top and bottom by the square root of 3. 20 times square root of 3 is 20 square root of 3. Over square root of 3 times square root of 3 is square root of 9, which is 3. Now, look to see, I cannot reduce the 20 over 3, so I am done. Number 2. I'm going to rationalize the denominator by multiplying top and bottom by the square root of 5. So that's 2 square root of 5 over square root of 5 times square root of 5 is 5. And I'm done. Look at number 3, square root of 6n over the square root of 8. Well, I can do one of the two things. I can rewrite it, putting it all over one radical, and then simplify. 6 over 8 reduces down to 3/4. And that's 3n over 4. Then separate the numerator its own radical and the denominator its own radical. And square root of 3n, I can't do anything with that. Square root of 4 is 2, so I am finished. Now what if you didn't see that? Let me erase this. Let me scoot this over to give me some more room. Oh. Okay. Now what if you didn't see, you forgot to reduce it? And you just went straight to rationalizing. Would I multiply the top and bottom by the square root of 8? Or would I multiply top and bottom by the square root of 10 to get a perfect square of 16? I would definitely multiply top and bottom by the square root of 2. So my numerator is the square root of 12n over the square root of 16. Now 12, I am going to break that down to 4 times 3 over the square root of 16 is 4. Square root of 4 is 2 square root of 3n over 4. And then I'm going to reduce, and I get square root of 3n over 2. And that is my answer. So you can do either one. Now number 4, I can do this several ways. I could put this radical all over 1 and reduce it to 1/2. Or look at the denominator. What is the square root of 100? That's 2. So I'm just going to rewrite -4 square root of 50 over 2. Square root of 100 is 10. Am I done? No. Square root of 50, I can break that down to 25 times 2. Square root of 25 is 5, and 5 times -4 is a -20, square root of 2 over 10. And then I can reduce that to 2. So my final answer is -2 square root of 2. Number 5, I cannot simplify 18 over square root of 6, so I'm just going to rationalize the denominator by multiplying both top and bottom by the square root of 6. So that's 18 square root of 6 over 6. Now 6 goes into 18 3 times. So my final answer is 3 square root of 6. Number 6, square root of 20 over 3. I cannot reduce that fraction. So I am going to have to put square root of 20 over its own radical and square root of 3. I'm going to rationalize the denominator by multiplying both top and bottom by the square root of 3. So in the numerator, that's square root of 60 over 3. Now look at square root of 60. I can break that down to 4 times 15. Square root of 4 is 2, so that's 2 square root of 15 over 3. And that is my final answer. Number 7, square root of 3 over 20. I'm going to break that down to say square root of 3 over the square root of 20. Now, I need to rationalize the denominator, so I need to multiply square root of 20 times something that's going to be a perfect square. Well, I know that square root of 100 is 10. So could I multiply 20 times something to give me 100? Sure, 5. And it would be square root of 5. So that's square root of 15 over the square root of 100. And that square root of 15 over square root of 100 is 10. Number 8, what is that 3 doing in front of the radical? It's just a coefficient. Ignore it for just a minute and look at square root of 10 over 2. What is 10 over 2 reduced down to? 5. So you just bring down the 3, and square root of 10 over 2 is 5. And you're done. Number 9. Okay, I think I did this problem already, but I'm going to do it again, and I'm going to do it a different way. I'm going to reduce it. I'm going to put it all over one radical, and I'm going to reduce to 1/2. So that's -4 square root of 1/2. That's -4 over the square root of 1 over the square root of 2. I have to rationalize the denominator. So that's -4 square root of 2 over 2. Simplify. So that's negative 2 square root of 2, and that is your answer. And that is it.